This podcast was created as a part of Podcast Lab by India Film Project in association with Anchor by Spotify. Is it the Ethereum killer? Will it replace other blockchains? While technically it stands above Cardano on rankings, but there's one thing we're definite of. It is an altcoin. Hello, my name is Anshuman Sharma and you have tuned into What's an Alt Was. It is a show where I talk about unique projects that have carved out their niches in the growing decentralized world. Every week, I will walk you through the adventures of the altcoin universe and help you with your growth investing. Keep listening to know more. This week's episode is about Solana, which is a layer 1 solution that boasts of high transactions per second. Technically, it is a high-performance blockchain with a very low block time. If you want to catch up with what networking layers are in blockchain, check out my previous episode on the Polygon network. Coming back to this episode, we have Audius, Tether, and even USDC partnering with Solana. One of the most anticipated partnerships arrived just in time for this episode. Brave has launched its own Web3 wallet and is in line to integrate Solana within its ecosystem. Before understanding the one-worded problem, let's have a quick look at various consensus mechanisms. Imagine that you are in a class of 30 students and your math teacher left a set of questions to be solved. Now, when each student solves the problem, they spend their time finding its solution. Some students find the answer within a short span of time, while others take longer to reach the final answer. This is similar to how nodes in a proof of work mechanism add blocks. Each block is similar to a math puzzle, and people with computing power are akin to students. One with more computer power, or knowledge in case of the example, solves the problem quicker and is awarded the responsibility to mine the block. He, in return, gets to keep a part of the transaction fees. When the teacher returns to the class and asks for the solution, the kid with more number of right answers is poised to win a chocolate and be considered strong for the class monitor's role. This is similar to proof of stake consensus mechanism, where validators who stake more of their coins have high chances of validating a block. Therefore, the probability of mining a block is proportional to the staked number of tokens, which is similar to investment of students' interest in solving the problems. Since very few participants are involved in the mining of blocks, there is a considerable increase in the TPS rate. Now, when different networks adopted proof of stake from proof of work, the TPS rate did not change dramatically because of one factor: finality time. It is a time taken to ensure the finality or immutability of a transaction in a blockchain. When a block is mined in proof of work consensus mechanism, it contains a timestamp of the node owner's region, but the verifying node owners may not necessarily be in the same region. This makes verifying transactions a lengthier process because the data now has to be verified by different node owners who may be in different regions. This adds to the low throughput even in the case of proof of stake consensus mechanism. Also, since there is a higher input cost in mining a block, less throughput increases the gas fees of the network. And hence, we have identified two main problems with most layer 1 solutions, namely low throughput and consequently higher transaction fees. Enter Solana. Solana is a public base layer blockchain protocol that is optimized for scalability. Its goal is to provide a platform that enables developers to create decentralized applications without needing to design around performance bottlenecks to operate at sub-second settlement times and at low transaction costs. Solana stands apart from the crowd by using a system called proof of history in association with the proof of stake consensus algorithm. In order to decentralize the concept of timekeeping, Solana marks the passage of time using events that are encoded in blocks. It is like saying that you went out of the house only after you wore your shoes. One event is authorized only when preceded by a set of previous events, which, if true, marks the passage of time. The events are encoded in a blockchain using an encryption algorithm like SHA-256. What SHA-256 essentially does is that it takes data and uses a hash function, much like your mathematics function, to create an output that is of fixed length. The input can be a text or an image or even a videographic information. All of them, when passed through the function, have an output of the same length. Here is an example from the white paper to help you better understand the process. Imagine clicking your picture with a New York Times edition that has a date printed on it on day 1. Next day, this image of yours is published in the New York Times itself. This authorizes that in order for your image to be printed on day 2, it had to be clicked before day 2's edition was published. Also, since the photograph contains the image of you holding the edition of day 1, it emphasizes that image was taken after the printing of day 1's edition and before the printing of day 2's edition. This way, Solana uses reference events in order to mark the passage of time and record a transaction, which in this case is a printed photograph. Solana has a very minuscule block time of 5 milliseconds, which means the leader responsible for appending a block is changed every 0.5 seconds. This also comes as an advantage to validators who do not have to wait for the previous blocks to be confirmed to mint new ones because they can trust the timestamps and ordering of transactions. Since the transactions are timestamped even before the consensus is reached, the time spent on verifying transactions otherwise is saved, which allows for a higher throughput and lower transaction costs. Solana was founded by Anatoly Yakovenko in 2017. He held major positions in the top tech giants back then. In 2017, Yakovenko started working on a project which would later materialize as Solana. He teamed up with his Qualcomm colleague Greg Fitzgerald and they founded a project called Solana Labs. Attracting several more former Qualcomm colleagues in the process, the Solana protocol and SOL token were released to the public in 2020. Solana's vision includes achieving the scalability of a decentralized network using a high-performance blockchain. Building on its hybrid model, people at Solana are confident of achieving a transactions per second rate of 700,000 on a standard gigabit network. Anatoly's prediction involves the famous Moore's law, according to which the CPU cores increase every few years. Since the verification of transactions on the Solana chain can be processed parallelly, a higher number of CPU cores will increase the TPS rate eventually. Solana's native token is SOL, which is used for staking, paying transaction fees, and to promote the growth of the blockchain. Crunching on some numbers, we have SOL, which is ranked 5th on CoinMarketCap with a market cap of about $67 billion. It is currently trading around $220, clocking almost 9,000% return on investment in the past 1 year. It also reached an all-time high of $258. Solana's native token SOL has a limited supply of around 500 million coins, with more than half of them in supply. While it is meant to be an inflationary coin, but the inflation rate will eventually be capped at 1.5% in the coming 10 years. It has around 1,200 validators that are providing it a TPS rate of more than 2,000. Solana's partnership with leading companies has shown how promising this hybrid model of consensus is. Moving forward, different blockchains will eventually mark their own territories. Solana's high throughput is of particular advantage to dApps that wish to scale to a larger group of people. A higher throughput, such as the theoretical number of 700,000, is a concern to many because of the consequent amounts of data that will need to be stored at each node. The network then aims to utilize their proof of replication model to build upon its own hybrid extensions, but only time will tell how successful it will be. As of now, we can see a vast majority of people flocking towards the benefits of this blockchain. It can be a good investment opportunity. But hey, remember that this content is only meant for educational purposes. That's it for today's episode. I know this isn't the whole explanation of the tech behind the application of this blockchain, but that was out of the scope of this episode. I am too learning more about it with each passing article. So don't be sad, I have linked some amazing references in the description box for you to check out. They'll help you learn more about the project. If you like this episode, do not forget to rate it on Apple Podcasts. If you're listening to it on Spotify or Google Podcasts, just remember to hit that subscribe/follow button so I slide down your feed with new episodes each week without even disturbing you. Also, one major announcement. Transcripts to all the previous episodes and to all the episodes from now on shall be made available. Check out the link bit.ly/whatsanaltverse. It will also be there in the description box. Until next time, keep exploring, keep growing, keep learning.